division. I'm recording class, by the way. There are, we'll talk about it after, but I'm going to show you what synthetic is. So if I asked you to divide you could use long division, but I'm going to teach you a new process today, but we're going to talk about when it works and why it only works, or just when it works. And so you can't use it for every single problem. So that's why I had to teach you long division, because long division works no matter what the problem is. Synthetic only works for certain types, but it is super fast. So here's what we do for synthetic. The same thing has to apply. It has to go from 3 to 2 to 1, which we're missing the x to the first power. There is nothing there. So I'm going to fill that one in, and then -4. So I would think of this as 2x cubed minus x squared plus 0x minus 4. So here's the setup for it. I'm going to make a little box, and what goes in the box is whatever makes this 0. So what makes that 0? Your answer should be 3. And then you go and you write the coefficients for all of the x and all the numbers up here. So I'm going to write a 2, a -7, a 0, and a -4. Please let me know if you understand where the setup came from. The 3 is because that's what makes what I'm dividing by 0. And then I wrote the coefficients down from all of here. Does that make sense so far?
Yeah, I follow.
Now we're going.
It makes sense.
We're going to do this same process over and over. So please watch. The first thing we have to do is drop this down. So we write a 2. You always drop the first number. Then this process of whatever's down here, we do the same thing. So we're going to multiply 2 times 3. 2 times 3 is 6. We write the answer of that in the next empty slot over. So I put a 6 here. And then I add these together. -7 and 6 is 1. I'm going to do that same exact process over again. 1 times 3 is 3. The answer to that goes here. Add these together. 3. Does that make sense so far?
Yep.
Oh, wait, I messed up. You guys should have caught me. I thought I messed something up. Where did I mess up? Help me out.
-1 instead of positive.
Yeah, because a -7 plus 6 is a -1. That's my fault. So this should have been a -1. Then -1 times 3 would be a -3. Sorry about that. Does that make sense now?
Yeah, that makes sense.
Yeah.
Sorry. Then -3 times a +3 is a -9. Add these together and you get -13. Now, does that look like an answer to a division problem?
No.
What were all of these?
Coefficients.
So what do you think all of these are?
Coefficients.
Now, what was the last thing whenever we did long division? What was that last thing that we had that was we called the leftovers? What was that called?
A remainder.
Remainder.
So if this is the remainder, what do you think this is? It's the constant, meaning the x to the 0 power. What does that mean this one is? I didn't hear you, Taylor. Whoever talked, I didn't hear you. What is this one then? This is the remainder. This is the constant. This is the x to the first power. What does that make this one then? No, no one? Okay. This is the x to the second power. You're just walking your way backwards. So remainder, constant, x to the first, x to the second. So my answer would be 2x to the second minus x minus 3 minus, since this is the remainder, you put it over what you were dividing by, just like we did with long division. Did that make sense?
That makes sense.
Yeah, it makes sense.
So another one, I'll do it quickly, and then we got one more thing to cover. But actually, I guess I'll do it now. How do we know if something was a factor before?
If there wasn't a remainder.
So remember how there was a remainder of, what was it, negative 13? That would have been a 0. That would tell me it's a factor. All right. Do x to the 5th minus 5x cubed plus 9x squared minus x plus 3. And I ask you to divide that by x plus 3. I'm going to go much quicker. What makes this 0? Negative 3. Make sure from 5 to 4, which it skips, then 3, then 2, then 1. So I got to go, what's the coefficient here since there's nothing there? A 1. There's no x to the 4th, so I put a 0 placeholder. Then I write negative 5. Then I write 9. Then I write negative 1. And then I write positive 3. Those are all the coefficients from right here. Drop the first one down. 1. 1 times negative 3 is negative 3. Add together, negative 3. Negative 3 times negative 3 is a positive 9. Add those together, 4. 4 times negative 3, negative 12. Add those together, negative 3. Negative 3 times 8 times negative 3 is a positive 9. Add those together, you get 8. 8 times negative 3 is a negative 24. Add those together, you get negative 21. So what's my final answer? This is my remainder. So this is the constant. So this is x1. This is x to the second, x to the third. That's x to the 4th. So I have x to the 4th minus 3x cubed plus 4x squared minus 3x plus 8 minus 21, the remainder, over, what was I dividing by? X plus 3. Did that make sense?
Yeah, that makes sense.
Now, what someone might ask me in this original problem is they might say, is this a factor of this? And all you're doing is looking at it, and if this equals a 0, that means that this is a factor. If it
Wait,
is not,
sorry.
say that again.
Sorry, how would we get like the bottom numbers again? We move the first one down, and then how would we get the second one? Like the next ones?
So I start here and go, this is my remainder. So this is my whole number, meaning my constant, no x value.
No, like when we're doing it, we move the one down and
Multiply
like
here.
Okay.
And whatever your answer is goes there.
All right, thank you.
Add them together and then repeat. Multiply, answer, add, multiply, answer, add. Same thing over and over. Now, with this, what if someone asked me, is this a factor of this? They're not asking me to do the full division. They're asking, is it a factor? Yes or no? Since this is not a 0, your answer would be no. Then the last thing I need to show you really quick is, maybe I'll save that for tomorrow. I guess I can do it probably really quick. If I asked you to do, someone said, hey, I want you to do negative x to the 3rd plus 6x squared plus 12x plus 325. Actually, I'll wait till tomorrow. I don't want to force that. Does everybody understand what we did so far with synthetic division?
Yeah.
Yeah.
Now, please remember, when I do division, if I said 10 divided by 5, what does that equal?
2.
How could you rewrite 10 then?
2 to the 5th power.
No.
What do you mean? Oh.
5 times 2, right? Why?
Yeah.
Because these that's called a fact family. If you got 10 divided by 5 is 2, then 2 times 5 has to equal 10, yes? So if I tell you that when I divide, if I divide x, if I take x minus 3 and I make it go into, I take 2x cubed minus 7x squared minus 4, and I divide it by x minus 3, and I tell you your answer is x squared, 2x squared minus x minus 3 minus 13 over x minus 3. If I tell you that's your answer, think about this right here. What does that mean for this? That means I could actually rewrite that as x minus 3 times 2x squared minus x minus 3 minus 13 all over x minus 3. If this divided by this is this answer, then this times this kicks me back to that, which means anytime I have this, I could rewrite it as the multiplication of those two things. Just like we said with the 10 divided by 5 is 2. That means I can, anytime I see 10, I can write it as 5 times 2. Because 5 times 2 is 10. Anytime these two things are equal, you can rewrite it. This times this equals that. That means that you can rewrite this as this times this. Does that make sense?
Yeah, that makes sense.
You will have practice on that tonight for homework. Oh wait, what time do we get out of here? Oh, I got plenty of time. I got 57. I was looking at the wrong time. I got plenty of time. All right, so the last thing I need to cover is this thing called the remainder theorem. The remainder theorem is really awesome. If I gave you a problem like this, it's a different way of using synthetic division, so please don't get it confused. I'm doing the same process, but the way I'm using it is a little different. If I asked you to give me f at 8, what am I asking you to do? What does this mean?
We're gonna have F and A on the left side.
Yeah, but what does that mean I'm going to do with all my x's? What is the
Divide.
f? No.
Replace the x with the 8.
Yes, that means that all these x's are going to turn into 8s, yes? And then what do you have to do? You would have to do, and notice where I plugged in, when I put the parentheses, I put that negative out here. That doesn't matter, by the way. You would have to simplify this, it would turn into a number. You would simplify this, it would turn into another number, whether it's positive or negative. This would simplify to a number, and then you'd have plus 325, and you would combine all these numbers, and you'd get a final answer. You should know how to do that. Today, I'm actually going to show you another way that you can do that. You can actually use synthetic division to find that same exact answer. It would be the same exact thing as if you plugged in a positive 8 in for all the x's. It's just a different way of getting it. You actually use 8 as your number that you're going to synthetically divide this with. You're still going to write all the coefficients from up here and make sure it goes from from the highest power all the way down to 0. So -1, 6, 12, and 325. There was no skippage, so we're good. And you're going to do synthetic division. You're going to drop it down. -1. -1 times 8 is -8. Combine -2. -2 times 8 is a -16. That goes here. Combine, that's a -4. Multiply here, you get a -32. When you finally do this, you get a 293. I am telling you right now, if you plugged in 8 into all of these x's and you simplified it, at the end when you finished, you would get 293. This is called the remainder theorem. It means instead of plugging the 8 in, you can use 8 as your number that you do the synthetic division with, and whatever your remainder is would be the same thing as if you had plugged in the 8. Does that make sense?
Yeah.
Now, here's the difference. What is this question asking you to do? If I said, I want you to do this. This is, I'm showing you where sometimes people make mistakes. What are they asking you to do in this question?
To divide.
You're actually going to do the division. So your answer is going to be the full equation. Like it'll have some x to the third, some x to the second, blah, blah, blah. Have that whole answer. Yes?
Yeah.
What is this question asking you to do?
Substitute the x's for 6.
And what can you do instead of substituting in 6 for all the x's? Instead of plugging in 6 here, 6 here, 6 here, and doing all that math, what could you do instead?
Synthetic division.
And whatever your remainder is would be your answer for this question. So when you do this, all you're looking for is the remainder, yes?
Yeah.
When you do this division, you're looking for all of it together. Do you see the difference between them?
Yeah.
Now, with synthetic division, you can only do synthetic division if you have minus some number. You cannot do synthetic division if you have 2x minus 1. You cannot do synthetic division if you have x squared minus 3. You can only do synthetic division when you have like x plus 3 or x minus 2 or x plus 7. Anything like this, you can do synthetic. Anything like this, you must use long division. So I had to teach you long division because you have to be able to do things like this, and it always works. Technically, even if someone asks you to do this, you could do long division and it will still give you the same answer. However, you cannot do synthetic division with these guys. So I have to teach you how to do long division because it works for everyone. Synthetic division is just a quick one, but only can be used in certain scenarios. Does it make sense when you can use it and when you can't?
Yeah,
Yep.
makes sense.
Does anyone have any questions on synthetic division or the remainder theorem or if the factor theorem. So if I ask you to do a division problem, and I said this, what is going to be in your box? I didn't. No. Yes. For the division, what makes this 0 goes in the box. If I said f at 2, and I said I want you to use the remainder theorem, what goes in your box?
The 2.
The 2. Do you see how people mix those up? What makes this 0 goes in here. The actual what you're plugging in goes in there. What is my answer if I'm asking you for the division? What's the answer? Is it going to be the part of it, or is it going to be all of these things being the coefficients as the answer?
The coefficient.
All of them is going to be the answer, right? If I'm asking you just for to plug 2 in, what's going to be your answer? Only the remainder. And if I ask you, hey, is this x minus 2, is that a factor of whatever? I don't care what the equation is. If I ask you if this is a factor, you're going to do long division, or you're going to do synthetic division, and what are you looking for right here?
0 is a remainder.
If it's a 0, yes, it's a factor. If it's not a 0, anything else, it's not a factor. Those are the 3 types of questions you're going to see for tonight for homework. Do you have any questions on any of those?
No.
Tomorrow, all I'm doing is going over both homeworks from both nights. Long division, synthetic, factor theorem, remainder theorem. So you're practicing all those tonight. And then we're going to come in and make sure you know what you're doing. So tomorrow is only homework questions. So please do the homework. And if you don't understand, have a question ready for tomorrow.
Which one did we do today? What was it called?